Hi everyone, welcome to 240 Quality. We're doing session 11, Statistical Process Control. Now we're out of whack on our sessions because we decided to jump ahead on 13 and 14 for the tools for the QI macros so that you could use that within your 30-day window. We don't want you to have to spend any money to extend that. So just to get all of the different QI macros done within your period there. Okay, this chapter is review for chapter 17. Okay, it's really about revisiting the histogram from chapter 15, which is like why we use one and how statistical process control, or SPC, works with it. Okay, we want to answer some of these questions with the histograms. They help us to see the information. They help us to see where are the values centered, what are the averages, how spread out are the values, what are the ranges of those values, and then are there any changes in the values over time. So you'll have some historical data in there as well. It's important to know. Okay, so we have SQC and SPC. SQC is statistical quality control, and it refers to using these statistical methods to monitor and maintain your quality. So what's really important to understand is that we want to find out what the products and how they're doing before it gets to the end product inspection, because by then, right, it's all going to be rework, or you're going to have to trash it and redo the whole process. So we don't want it to be later and beyond too much help that where we can fix it. We want to be able to fix these things as we're going along. So we call this one method is called acceptance sampling. It is done to determine whether or not to accept or reject a group of items based on the number of defects that are found in there. So it's really between a compromise between 100 inspection and then no inspection at all. Okay, your classical inspections. All right. The second method is statistical process control, and that's referred to, it uses the graphical displays known as control charts. And we've talked about them in the past as well because we already did a little bit of them. It tells us whether or not our process should be continued, or do we need to adjust it. Okay, let's go to SQC. Statistical, and then this is from your book on page 219. The use of numbers and data to study the things we do, okay, how well we do them, the characteristics of our process, in order to make them behave the way we want. So we want to be able to control it better, okay. Back to this, we want to understand that it's important to know that most poor quality is not the worker's error. It's really due to the defect in the actual manufacturing process, the way the management has made poor decisions maybe in their systems, and then just design to get all together the design of the process and the product. So we have to think about that all over. Okay, now statistical thinking. It uses a scientific approach, such as the scientific method, to solve problems. It's decisions to make changes based on the data and statistics. So it's really data driven. We have to remember that's what's important. If you have the data and the facts in front of you, they're really not going to lie. And again, taking sampling, and that's what we're going to talk about next, is sampling and how we make sure that the samples we take are really good samples to make our data really real. Okay, the foundation for SPC was around 1920. It used mathematical laws and centered around probability, how often certain events occur under certain circumstances. So Shewhart was the actual person who we consider to be the father of SPC. He discovered patterns and variation while measuring and recording the data. Do you remember he talked about the helmets for the heads of the headsets? Most measurements cluster around a midpoint, or the average, and then the farther away from the average, the fewer the frequencies. So we have that bell-shaped curve, which you see in your histograms. Variation is found to be present in manufacturing processes, and creates charts, control charts, to record and represent this variation. Okay, and we have talked about these in the past couple of weeks. Okay, now when we're going to talk about collecting data, so we really must understand what a population is in the samples. So the population is really just basically all the members or groups, elements of a group. Who it is, the whole population of who it is you're going to be, or the topic of your sampling. A sample, though, is a small portion of that population. All right, so take a look here. So we have this whole population of interest, and then our sample are going to be these people randomly picked out of that population, assuming, right, that they all have similar types of attributes that it is that we want to collect around. Okay, a representative sample. So patterns in a sample of units may be reasonably attributed to the population from which the sample is drawn, but only if the sample is representative. So in practical terms, it ensures that your sample is almost always being a random type of sample. Here's an example of what we're talking about. Population, all batches of a product made at a specific plant. Sample one batch of that product at that plant. Okay, so that's what we're talking about. So you're going to like take, okay, you might be seeing a problem and it seems as if you found a pattern. They're all coming out of one plant. There's a problem. So that's your population, that one particular plant making that particular product. So let's take one sample and let's look at one batch, and that's how you resolve your issues. Okay, now we're going to talk about attribute and variable data, and we have already covered this. Okay, we talked about how attribute data is discrete data and variable data is continuous. So let's look at examples again. So data obtained by counting items that conform. This is data obtained by measuring a process variable. So over here, when we say discrete data, yes or no, go or no go, meet or fail to meet. Variable would be data like measuring a process variable like 45 gallons per minute or 99 psig or 75 degrees. So here you're just taking an average, or you're looking at this instantaneous data but collecting it over time. Okay, continuous. This is qualitative and this is quantitative. Okay. All right, so let's talk a little bit more about attributes data. Good or bad product, percent of late shipments from vendors, or how many mistakes per batch. Here's an example of variable data. The flow rate through a pipe, volumes of tank in gallons, temperatures of the process stream or reactor pressure, PSIG. Okay. All right. Now the frequency table and the histogram. So there was an example that you already should have done, the condenser temperature reading. So we had looked at this data and you should have done a histogram on it and some on the chart. So this is the data and you should have had that already in an example. So we're just going to go through this quickly. So just condenser temperature readings and then the frequency of them occurring, right? Those temperature readings, you just collect the data and then you plot your histogram, and this is how it looks. Okay, so this is the temperature and how often it happened, and you can see here this is that typical bell-shaped curve. Okay, so this is a really perfect bell-shaped curve, and then this is the amount of the sigmas. Remember, we take the center line and we say how many deviations from the average and the area where it's supposed to be almost 100% accurate here. That's our middle column, and then we have 3 deviations or sigmas, right? 3 sigmas on one side and then 3 sigmas on the other side, and that is where you get that 6 sigma term. Okay, so we just talk a little bit here about the properties of distributions, okay, and what they do mean. So the location or central tendency is where are the values centered, or where are they located? How far apart are they? And what is this? Are there any changes in the values over time? So does it shift? Okay. Now we've talked about these in the past, and then this also talks, again, we've talked about how the histogram helps you look at that information. And when we did our process capability, we said we could have them all looking like a nice perfectly bell-shaped curve, but they could be shifted, which means your data is really off. So even if it looks like a perfectly bell-shaped curve and your CP is a number like above, what is it, 1, right? Anything above 1 is good, but it doesn't mean it really is a good process, and we've talked about that in the past as well. Okay, now this is the bell curve and the symmetry around the center. That's your normal distribution. Okay, so let's talk just about these quickly because we've talked about them before and I don't want to belabor the point. So location is your average or your mean, right? We've talked about these terms, mean and average. Your spread or your range gives you that standard deviation. So central tendency, the median, the mean, the median, and the mode. So the mean is another name for average. We've talked about that before. We call that an X bar for our X bar charts. And anything that is not in the average area is seriously out of the average. We call them outliers. But we're not going to calculate the sample mean because that's just an average, and you can easily do that in Excel. Again, remember, we're not going to waste our time on things that we can have Excel do when we have the ability for that to be done. And it's just getting the average of a number. I'm skipping this. The median is the data that sets the two apart. Half the data will be greater than or equal to the median. The other half will be less than or equal to the median. And again, you can have that calculated, but it's calculated by arranging the values in their highest to lowest and finding the middle of that data. It's the median, the middle of the range. Sorry about that. So it's another name for 50th percentile. Okay. So we're not going to again talk about that. Calculating it, that's not, again, we're not going to do this. All right, calculating sample mean, again, we're not worrying about that. Now the mode. The mode is the value that occurs most frequently. One set of data could have many modes, all right? That's something else to look at. And then spread and range. So the range is the difference between the highest and lowest data, and the spread is a standard deviation related to the distance from the mean, which is the average. I'm sorry, it was variance. Now, variance measures how far each number in the data set is from the mean, S squared. Now, there's no way that I'm going to have you calculate this. Again, your Excel spreadsheet, whether or not you have QI macros, has all of these. It'll be under statistics, under the statistical sets of calculations and the statistical tools. Okay, so you go under in Excel, and I might show you that at the end of this really quickly how to find that, even if you don't have the QI macros, because this is just normal statistical data that you'll find all the time in Excel. So, and this is just an example for the variance, and we're not going to calculate it out. Again, you would let Excel do it. So if, sorry, my mouse keeps moving. If measuring variance of population is denoted, then this is sigma squared. Then the sample denoted by S squared is S squared. So it's just giving you, again, just giving you more data on how far away from the average it is. A standard deviation is the sample standard deviation is the square root of the sample variance. So it's just taking that variance, all right, and squaring it. Again, you can look that up in there. All right, standard deviation in the normal distribution. So again, your bell-shaped curve shown by the histograms when you do them, and your sigmas from the average. 1 sigma, 2 sigma, and 3, so that's your +3, and then 1 sigma, 2 sigma, and 3 in the negative, and so that's a -3 sigma. So again, just how far away are you from one side to the other on your upper range and your lower ranges, and then that overall is your 6 sigma. And we've talked about this before. Okay. Okay, now, so do the homework in there. There's just a homework assignment on that basic statistic problems. And again, I want to show you how to get to that in Excel, so we'll do that really quickly. And then make sure you're getting done your quality project. So just get working on that. I've had a few people give me their information, and they look really good. And I just want the rest of you to remind you about that. Okay, so if we go to Excel, I just want to show you where these tools are. Now you might only see parts. So if you go to formulas, all right, more functions, statistical. So you hear average. Okay, I'm scrolling down. We'll get to the M's. We have the median, the minimum, the mode. There could be multi-mode, single mode. What is your distribution? Normal distribution. And then you can have over here your standard deviation. They're all different ways of calculating standard deviation. We keep coming down. Now we have variances, okay? So there again, everything is already in here normally in Excel because I don't have QI macros posted. So again, I just wanted to show you that. So let's just quickly go back to our PowerPoint. So continue to work on your project, and I hope to meet with you today, or we'll have met today on Zoom just to get a catch up. So we have this week, the next week. Okay, 2 weeks left of work. Next week, I don't believe you have any homework. So just continue to work on your project. And then the following week, I want your projects posted, your PowerPoints and the report, and then also the final exam. And that's all of your 3 tests. And then with any of the information in between, and again, open book. So you should be fine. All right, you guys, I'll talk to you soon. Have a great day.